This is Jack Brook at Columbia Gorge Community College, and in this session, what I'd like to do is take a close look at food labeling. As you may or may not know, food labels have been around since the early 1990s, but as of this year in 2020, they have been changed. So I'd like to take a close look at the changes in the food labels, but also because I don't think consumers have a good idea of what information they can really get off a food label, how to read food labels. And so what I'd like to do is show you all the good information you can get off of those, how you can use it, and look at them pretty closely. As on the screen, what you can see is there's a difference between the old food labels and the new food labels. The new food labels were supposed to go into effect in 2018, but because of feedback that the companies didn't have time to produce new food labels because they have to go back and reprint them and everything. They wanted to be able to use up their old food labels before they had to make new ones. So the government basically said, okay, we'll give you until 2020. So most of the food labels, you might still see a trickling of some old food labels, but most of the food labels are now what you see on the right-hand side. And you can see there are some differences. There are some differences in the font size. There's some differences in the serving sizes, and there are some differences in the types of nutrients that you'll see on the food label. So I want to go over that a little bit. Um, if you look at, let's just look at a new food label and show the difference, or talk about the differences between those. As you can see, some of the new information that has a different font size, serving information, if you see number one, has changed, and we'll go over that in a little bit. The calories are the font is a lot bigger. Um, but what I want to emphasize is amount per serving. So as you can see in this food label, there are four servings if you look up in the serving information. And so all of the information you see in that food label is dealing with one serving. So if you ate the whole container, you just multiply everything times 4. And so instead of 280, you take 280 times 4. And A lot of people don't know that. They don't look at the number of servings. They just think that there's 280 calories in the whole container, whatever that is. But it's per serving. And the serving size in somewhat can the producer can determine that, but there are some specific serving sizes that have to be used based on what people normally eat. So you see the calories are different. The nutrients are pretty much the same. The only thing that's different from the old label is that you can see the included added sugars down close to about 3/4 of the way down. You'll see includes added sugars. So they haven't added that to the food label so that consumers know the difference between a natural sugar, which, for example, you would have in milk, like lactose in milk, or fructose in an apple, something like that. But if you add sugars to them above the natural sugars, then that has to be in that category. Uh, and then you'll see that down at the very bottom, if you notice the difference, there's a difference in the nutrients. So vitamin D has been added, potassium has been added, vitamin A has been removed, vitamin C has been removed, and these basically have been determined by some of the surveys we've gone over. Um, and they determined that these are nutrients that the public needs to be aware of. So that's kind of the new food label. So we're going to use that information and show you what you can get off that food label. There are some exceptions. For example, when they first started doing these food labels, the government said, well, your food label has to look like this. And then, but some of the tuna people and other um, producers that had specific cans which they consider to be their standard of identity. And their standard of identity is, tuna is in this size of a can. It's always been in this size of a can. So we don't think we should have to change our size of can to fit the labeling requirements. And it does have some reality because, tuna, you have to cook it and everything. So, the size of can can make a difference in your cooking times and that kind of thing. So they relented and basically, okay, your label can look like this. So it's a little bit more condensed, but pretty much all the information is on there. Then another example would be if your product has no nutrients whatsoever, there's no need to list all the vitamins and minerals with a bunch of zeros on there. You just have to list the critical information that's on that for calories. How do you determine calories? Where are the calories coming from? That kind of thing. But listing the vitamin D and the potassium and iron and so forth is there's none in there. So why make you do this? So if your product has no nutritional value, then you can have a simpler label, something like this. So there are exceptions. But the standard food label for all of the things is required. So just looking at the food label, you'll notice at the very top, it'll give you the serving size. So it'll tell you how many servings per container. So once again, all of the information, the vitamins and minerals and everything on that food label are based on one serving size or one serving. And so this one, everything you see on the label is 1/4 of the whole container. Um, but there was some changes in that the serving size used to be whatever the producer wanted it to be. But the serving size now has to reflect what people typically eat. It's not recommended how much you eat or a recommendation of how much you should eat or drink is just what a standard serving size would be, and then all the nutrients are based on that. Um, so anyway, as a consumer, you need to make sure that if you're talking to somebody, you're explaining it to people, they need to understand that they need to look at how many servings are in that container and make adjustments accordingly. The calories are based on a serving size. So this container for 1 cup is 280 calories. But obviously there are 4 cups in this container. Uh, and so you'd have to multiply times 4 if you ate the whole thing. Um, and so that would be 1,120 calories if you eat the whole thing. So again, some consumers don't realize that and they think, oh, I can eat the whole thing and get 280 calories because that's the main focus. You see it's a bigger amount, so they think it's the whole container. So that can be a misconception on there. Now, the daily values are an important piece, and I'll show you where they are, but the daily values are information about nutrients that in some cases don't really have a DRI or an RDA. Were put together to inform the public about nutrients that have a health concern. For example, saturated fat does not have a DRI or an RDA, and fiber doesn't. Added sugars really doesn't. That kind of thing. So these are important nutrients, though, that do have a health concern. For example, saturated fat, dealing with heart disease, sodium with hypertension, fiber with colorectal cancer, those kinds of things. So these aren't all the nutrients that are on the label, but just to give you an example, and I'll show you what the numbers are later on for all the nutrients. But these were, put together by so-called health experts with the FDA, USDA, so forth, and they basically came to a determination based on research that for food label purposes, saturated fat, the 100% DV would be 20 grams for sodium 2300. Now these numbers may be different in other guidelines that you might see, but these are the numbers that you need to know for food labels. And I will expect you to know these when you do an exam where I'll give you a food label. So this might be a good PowerPoint slide to print out and have available when you take your exam. Okay, so here's the percent TV. You'll see those on the food label and percent daily values. And then on the right-hand side in the purple, you'll see based on the recommendation, like for example, we said that saturated fat was 20 grams. Okay, well, this product had 4.5 grams, which represents 23% of that recommendation. Again, the recommendations are not really meant for you to reach 100%. For some of them, you don't want to reach 100%. For example, saturated fat, you would not want to reach 100%. But this basically tells you if the percent is a high percent or a low percent uh, based on the daily value. So it would be good that you should look at that to see if it's high fat or low fat. So percentage is a percentage of the daily value for each nutrient. The percent helps you determine if a serving of food is high or if it's low. And I'll go over what we mean by high or low in the quick guidelines. But again, these are not recommendations for everyone to base a diet on. For some of the nutrients, you don't want to reach 100%. For some of the nutrients, you want to reach at least 100% for like fiber during a day. So um, these are not meant to set as a meal plan for or something like that. And we'll go over what you should use these for, that kind of thing. But the other thing is that these are all based on a 2,000 calorie diet. So if you eat more or less of them, then these really are not for you. You wouldn't use these to reach 100% or less than 100%, but they're used as a guideline to say, okay, if I have a risk for heart disease, I want to choose a product that's low in saturated fat. And so we want the percentage DV to be as low as possible, okay, or cholesterol as low as possible. If you have hypertension, sodium as low as possible, fiber as high as possible, right? So there are some guidelines that we'll go over in just a sec on those. So here are the values. So based on a 2,000 calorie intake, in the red, you'll see what the values have been determined. So these are numbers I want you to know. You don't have to memorize them. You can write them on a piece of paper. You can type them out. You can print this slide, whatever you want. But have them available, because on an exam, what I'm going to do is eliminate some of these numbers for percent DV, and I will expect you, given the grams or whatever, I will expect you to be able to determine the percent DV for whatever there is one. So you need to have these numbers available in order to do those food labels. But again, in the red, these are recommendations that are come from health authorities. Doesn't mean they're right or wrong or indifferent. It just means that these are the numbers that are set for the daily values. And you'll only find daily values on food labels. So they are not guidelines like the DRI or RDA or AIs or anything like that. They're just meant for food labels only. Okay, so again, you can see that the percentage is based on, for example, if you have cholesterol, well, it's a bad one because it's 0%, but you basically 160 milligrams of sodium divided by 2,300 milligrams times 100 would give you 7%. So we'll work with those in a little bit. So these are the nutrients that you would be expected to get less than 100%. So when you're looking at those food labels and you're looking at the percent DV, then you would choose products that were lower on the lower end of percent DV for total fat, because again, you can see that these are related to health concerns. But on the other end, number two, you can see you want to get at least 100% for fiber, vitamin D, potassium, because these are nutrients that have been shown to be deficient that the government basically says we want the consumer to know so they can make a better choice on these. So what I also need you to know and what you should use, because you can't just go into the grocery store and look at every food label and read every single thing on the food label and try to figure it out. So the general rule is to use what are referred to as the quick guidelines, in that 5% or less DV is considered a low DV. 20% or more DV is considered a high DV. So what you're going to be doing as a consumer is, you're going to be looking at your situation, or this is what people should do, because you can't look at everything. I mean, you could if you wanted to spend 3 hours in the grocery store. But if you have a risk for heart disease, you would want to look at saturated fat cholesterol. You may want to look at sodium. If you're hypertensive, you don't look at sodium. If you're diabetic, you want to look at sugars um, and carbohydrates and those kinds of things. So if you're a diabetic, you would look for products that are 5% or low in added sugars, or potentially carbohydrates, low as possible in carbohydrates. If you have a risk for colorectal cancer, then you would want to look at fiber, and you would look for a percent DV that's 20% or higher. Okay. But the way these are supposed to be used, again, as you recall, I said the percent DV is not meant for you to base a daily diet on. What is meant to be used for is a comparison tool. So you take 2 cans of chili, and you look at the labels of 2 cans of chili, you look at the percent DV, and you look at the ones, because chili normally has a lot of sodium in it. So you would look at both products, you'd look at the percent DV for sodium for both products, and you'd make a determination of which product would be best to choose. And you choose the one that is closer to 5% sodium if possible, or the lowest sodium based on the quick guidelines, 5%, 20%. So again, it says to choose products that are higher nutrients you want to get more of, choose products lower nutrients you want to get less of. But again, you're going to just use the percent DV as a comparison tool to make a choice. But as you can see in the red, you need to make sure that the serving sizes are exactly the same, because you can have a product where the serving size is 1 cup and the other is a half a cup, and yeah, for sure, the 1 cup serving size is going to be higher in sodium, but as a percentage, it may not be. So make sure you look at the serving size before you make a choice. Okay, so I do need you to remember the quick guidelines. Remember 5%, 20%, because I'm going to give you a food label and I'm going to expect you to be able to look at it to see if it's considered high or low based on percent DV. Okay, so what I want to do now is go over a little bit of math. So for the next exam, you're going to need a calculator for sure. And what I'm going to do is white out some of the numbers, white out the calories, I white out the percent DV, and I would expect you to be able to determine what they are, because I want you to know how they were figured out. And so I think if you know how, then it will give you a better understanding of this. So the first thing we want to do is how did they get 280 calories? How did they come up with that? Um, and so based on our previous lectures, you should know how many calories are in nutrients, and you should look at the calories of the nutrients that are energy producing and to determine total calories. So again, what we're trying to say is, well, how did they get 280? And I might preface this to say that you're probably not going to come up with the exact calories because in most cases, uh, the labels will reflect a well, they'll either increase it or reduce it to make it 0 or 5 in most cases. It doesn't mean they have to, but they'll make an adjustment to just make it even, kind of a thing. So you probably will not come up with exactly the right calories on this. Um, but the next thing you need to determine then is what are the energy nutrients. So from previous lectures, you should know that total fat produces energy, carbohydrates are energy producing, and proteins are energy producing. Make sure when you're doing this though is that you understand that saturated fat is included in the total fat. So don't determine total fat and saturated fat because you'd get too big of a number, right? But the 17 grams includes the 11 grams. The 29 grams of carbs includes the 23 grams uh, of total sugars, um, and the the protein's a protein. So you know what the energy nutrients are. So what you need to do is determine then, okay, how many calories is in a gram of fat? So from previous lectures, you should know that there are 9 kilocalories per gram. So 9 times 17 will give you 153 calories. And then carbohydrates, you should know that they're 4 calories per gram. So it's 116. And for protein is 4 calories per gram, so it gives you 16, which gives you 285. What my calculation is 285. But um, for whatever reason, they were able to use 280. Now on an exam, I don't expect you to make adjustments. Just give me what you get, because sometimes you could get 282 or 287 or something. So you would just give me what you got, kind of a thing. So you just basically determine the fat, carbohydrate, and protein, and go from there and do it that way. Okay. What if you wanted to know the calories from fat? Now the old labels used to show you, but for whatever reason they took them away. Uh, but um, in some cases you may want to know what the calories of fat from fat are. For example, um, we'll stick with 280 calories, but say your product is 280 calories, but you may want to know, well, okay, out of those 280 calories, how many calories are from fat? What percent calories from fat? Again, our goal is, per day, 30% or less. Doesn't mean every meal has to be, but you could look at this and want to determine, this would be important. For example, if you buy pre-prepared meals, like we used to call them TV dinners back in my day. I'm an old timer, but I don't know if they still call them that or not. But pre-prepared were like, you go to the store and they're frozen and they have 3 compartments, one for dessert, one for starch, and one for meat or whatever. And it says, oh, only 280 calories per meal, right? And you're thinking, oh, that's a good, it's only 280 calories. I could have that for lunch. But the other part of it is, well, okay, how much fat am I buying um, from this? Let's face it, I think we might have talked about it before, but the 3 things that sell are sugar, salt, and fat because we like the flavor of all of them. Um, and fat is cheap. So the less expensive pre-prepared foods are probably going to be higher in fat. But how would you determine that? Well, basically, you've already determined the calories from fat. You know the total calories, 280. So, how you would do that is fat is 17 times 9 is 153. Uh, oh, and to determine the percent calories from fat, you would just take 153 divided by 280, and that would tell you that this product has 55% calories from fat. So this product you're eating is over half fat, which I don't know. But again, some of the cheaper brands, are going to be higher in fat because they're tasty. They're probably a little bit salty, and they obviously have a sugar dessert with them. But some of the better quality ones, there may be a higher price, but if you figure out the percent calories from fat, they may be less than 30. So that's something you may want to look like that as a consumer. But in any case, for exam purposes, I will expect you to determine the total calories. So I will just basically white out the total calories, um, and leave you with everything else, and you be able to tell me what the total calories are for that food. I would then potentially ask you a question, well, what is the percent calories from fat for that product? And then I would expect you then to be able to know how to determine that. Okay. And again, I just highlight at the bottom is all this information is going to be based on 2,000 calories that we're going to. So just emphasizing that. And then again, emphasizing the idea that the serving is 2/3 of a cup. So that's 280 calories for 2/3 of a cup, but it's also 55% for 2/3 of a cup, right? Kind of thing. And there's 3 servings in there. So you determine, based on that. Okay, the next thing is how did they figure out the percent sodium? So you can see on the label, you go down there, sodium's 100 milligrams or 4% DV. So how did they determine that? Well, this is where the numbers that I said you needed to have are going to come in to play, because I could blank out the 4% and I could ask you, okay, what is the percent daily value for sodium? Um, and so you look at the percent daily value, you say 4%, 100 milligrams, then you need to know what is the recommendation. So the DV for sodium is 2,300. So you basically just take 100 milligrams, divide by 2,300 times 100. That would give you 4.3%, but they were, excuse me, they were able to round down and to 4% because you normally can. It's kind of touchy, but in some cases you can't say you have less of some nutrient than you really have. Um, except like for calories, you can, or for calories, like I said, I don't know how they can go from 285 to 280 and say we have less calories than whatever. But anyway, um, so that's how you figure out all the percent DVs. So 20% cholesterol, you'd find what the recommendation is, divide 60 milligrams by whatever the recommendation is, 300, and get 20%, something like that. Okay, we've also talked about nutrient density. So the potential is, and what I've done in the past is have 2 labels side by side, and I've asked students to determine which of those 2 products is the more nutrient dense. So nutrient density, if you remember, is the amount of nutrients per calorie. So you already have the calories, 280. Now you just need to look at the nutrients and determine nutrients per calorie. So that's your formula. Nutrients divided by calories. So one example would be, okay, we're going to be looking at nutrients. Now, when you look at nutrients, we don't normally want to look at nutrients that have determined calories, but the other nutrients like vitamin D, calcium, iron, potassium, so forth, and look at those and do a comparison. But you can't just compare one nutrient. I'm going to just do one nutrient, but you can't just compare one nutrient because label A may be higher in potassium than label B, but label A, B may be lower in vitamin D than label B. So you have to do all of them and do a comparison and make a judgment based on all the nutrients. Um, what is the more nutrient dense? Okay. So in this case, you got 4%. It's kind of a goofy outcome, but 4% calcium divided by 280 calories gives you 0.014% um, nutrient per calorie. So you just do the same thing with all of those. 2% divided by 280, calcium 10% divided by 280, and then do that for label A and do the same thing for label B. Do a comparison and just determine based on those comparisons which one is more nutrient dense, which has more nutrients per calorie. Okay. And you can't really look at just the calories because some students I've had in the past, one label would have 280 calories, another one would have 400, and they say, oh, the label B is 400, so it obviously has more calories, so it's less nutrient dense. That's not true because if it has more nutrients per calorie, then it's going to be the more nutrient dense. Doesn't matter how many calories you have. The other term we looked at was energy density. And energy density is, the amount of calories per weight. Okay. So we know the calories, 280. And so where's the weight? Well, the weight's up here. You can see it's 106 grams per serving. I mean, you could use cups if you wanted to. That gets kind of goofy because you'd have to use 2/3. But if you use the gram amounts, you have 106 grams for every 280 calories, right? Or 280 calories for every 106 grams. So you basically just take 280 divided by 106 and you get an energy density of 2.64 calories per gram. So once again, I could have two different labels and I could say which one is more energy dense. And you would then determine that. The other thing I forgot to mention was, when you're determining calories, and I'm sorry I forgot this, but hopefully you'll get it, is that remember fiber really doesn't have any, it isn't used in the calorie measurement because fiber doesn't have calories. So if, for example, you see on this label you have 29 grams of carbohydrates, and if your dietary fiber was 9 grams, which is pretty high, but you would take 29 grams minus 9 grams and use the 20. So to determine your total calories, you'd only use 20 grams of carbohydrates. So once again, dietary fiber does not um, have calories, and so that would not, even though it's a carbohydrate, it's not energy producing. And so you would take the total carbohydrates, subtract the fiber, and then multiply that number times 4. And then that would be the best way to practice the food labels is just, take some food out of your cupboard and see if you can match their numbers within reason. Like I said, you're probably not going to get the exact numbers they have in the label because they can make adjustments. Um, But if you're close on the total calories, if you're close on the percent daily values, then you pretty much got it, right? If you're not, then you may want to contact me and see if we can figure it out. Um, but anyway, so this is a little bit of detail about the food labels, but I think if you get more detail, you fully understand them. So maybe you can use this to teach your family or somebody else how to read a food label so that they can make better choices. So the whole goal is to make better choices in your food purchasing. So I hope this helps. If you wanted to know where this label came from, I'll just let you know. I just got it off Google, but for whatever reason, Cornell University has a food science department, so they have a ice cream, dairy science uh, department, which makes ice cream. So all of the information that you just saw on the food label comes from these cookies and cream ice cream. All right, all right. So um, thanks for listening, and we'll talk to you next time.